our point of view, this is the first step in PLC programming. So if you have a student that never programmed a PLC, never seen a sensor, never seen a motor, first of all, you don't want to expose the student to mechanical danger. So you can have the process simulated. So here you have an electric boiler. So here we have 60 degrees. So it's simulation. It's safe for the student. You have a pump. You have some valves, and you have some heaters here. And the job for the student is to develop the PLC project, in which if the temperature, all these temperature are analog inputs in the PLC, if the temperature is dropping, he has to start the pump and open the valve. And you see here the PLC have opened the valve 1, the temperature increased, and we will see that after some time when it reached the set point, the PLC will close the valve. So that was the job of the student, to develop the project. And also each simulation has a page in which we have the functional description. We at ASTI, we have industrial background, so this will be like the client portfolio, what the client is asking. And here we have the functional description. And also here we have a basic IO list for the student, in which you will see that temperature 1 high is a digital output. The pump is digital, and here it's the input that is connected. So what the student has to do? First of all, here we see the end result, but the first step for the student is to make the electrical connection. So they can have some experience with electrical diagrams and the cables. Also, we are using safe cables. So here they are.
Very safe.
Yeah. You cannot touch the metal, so also if you touch the metal, it's 24 volts or 0 to 10 volts. But also, yeah, we have these AC connections, and this graphic interface is connected with this acquisition board, and all the inputs and outputs from the process are available here. The student is making the connection to the PLC. He can add other inputs if he want to have different scenarios, for example, automatic, manual, or something like this. And the job for the student is to focus on the software. If the student doesn't need to make the cabling, we have also this kind of connectors in which you have 3 connections, all the wires are pre-cabled, and you have to focus on the program. Yeah.
Excuse me, I have a question. So here is a simulation of, for example, a heating system with automation. So how can you make sure that, for example, this simulation is an implication of the reality in the real world? For example, if we have in the real world we have this kind of heating system, because the goal of this kind of education is to apply this technology for the real system.
Like I said, this is the first thing. So in the end, the student will need to have the sensors to understand what is a sensor, what is a valve, what is a pump. But in the first step, his job is to understand how to program, what is the basic blocks, what is an input, what is an output, and he can have with this kind of scenario, and this is scenario 39, so we have a lot of scenarios. He can learn how to program.
My question is that, for example, scenario 39, did you test it with the reality that, for example, if you turn this valve on or off, or make the pump on or off, react as a reality or not? Or in other way, did you evaluate your model, your simulation?
Here the model is very simple.
Or just do you expect that, for example, if we open this valve or open this pump, then the temperature will change in this way?
Yeah, so basically the simulation behind is not so complex, so we don't have continuous model of the temperature, because this is was not the case here. Also, if you can see in the wiring, we don't have a lot of analog. So for here, you have like a thermostat on the panel, which give you a digital, not temperature, the temperature is below set point, the temperature is higher than highest set point. So it's very basic simulation, for example. But like I said, this is the first step. Also, if I go in the menu, I can show you different simulations.
I mentioned because I saw that ASTI logo, your logo is under your simulation frame. So it should be also, it should include also some evaluation or validating.
Yes, but like I said, here we're not doing the process modeling, and we don't have MATLAB here. This is just, for example, this is more intuitive for the students that learn discrete systems, not continuous systems. So you saw the temperature, but there you don't have a PID control to have a model and something like this. You have just some levels, and it's if it's below level, start above. Yeah. And if you have the software here, also this will work in the real environment.
Actually, it's a training set that can help you to the student how to use the PLC, how to understand the programming of PLC using the signals.
And maybe after training R&D, he can.
Yeah, I mean, just for the student to have a knowledge with how to use PLC, like programming PLC or using different sensor to connect the PLC. In the real world, I mean, it
will be more complicated. And also, you have 16 inputs and 16 outputs will not be enough.
For anything.
If we are going in the other case, there are more inputs and outputs. And but here, yes, but basically when you start the program, the first step will be to understand TIA program. We are talking about Siemens, and to figure out different functions. And you can start, for example, with the first simulation, which is basic logic function. So the student has to input and output, and this output should be active when both inputs are active. So we start from very low, and the purpose here is just to get familiar with TIA portal, to know where is the download button, where is the upload button, yeah, and also the logic, where you can put the logic, what is a main program, what is a function block, what is a function. Then you have timers and counters, and yes, the difficulty is gradually increased. Mode on off, so you have a button to start, a button to stop, a contactor here, and you can start the motor. From very basic to more complex. For example, here we have a conveyor.
Visual Studio. C++.
Yeah, so right now here I have some software, some software. Basically, it's a conveyor, which is you can select here if you want 4 pieces. Depending on certain aspects of the start and the recipient, you should count all the pieces. So different kind of difficulties.
Thank you.
Yeah, so like this is the first step in program. Not a lot of hardware hazard, so here the student broke a finger or something like this. Not a lot of electrical hazard, so yeah, you can start and focus on programming. Yeah.
You go gradually this simulation, then you come up.